Okay, we've got two more problems, and these are a little challenging, but we can do them. And we're just going to stay truthful to what we're writing down. Okay, so when I look at this problem, the first thing that I notice is that I don't have the derivative of the square root of 2x present. All right. So that looks a little awkward, but that's part of the challenge. All right. So we're just going to go ahead and start with letting u equal the entire denominator, 1 plus the square root of 2x. Okay. And why do both terms and not just the square root of 2x? Well, the derivative of 1 is 0, so that's going to be easy for us to kind of get rid of. It's not going to cause us a problem. And if we go ahead and use both terms, then you can already see we're going to replace our denominator with one term, which could be to our advantage. Okay, one term in the denominator is better than 2 or 3 because if necessary, we could distribute it. All right, but we've got u equals 1 plus the square root of 2x. Okay, let's find du. Du is going to be 1/2 times 2x to the negative 1/2 times 2 dx. Remember, we have to go on the inside, take the derivative of the inside. That's where this 2 comes from. And so those 2's cancel out, and we are left with du equals 1 over the square root of 2x dx. Okay, well, so far we have an expression for the denominator. And what we now need an expression for is dx. Okay, we normally don't multiply both sides by a variable, but we're going to do it this time. If for no other reason, we don't have anything else we can do. Okay, so we're going to say this is du, or I'll write square root of 2x times du equals dx. Okay, well, the other thing we don't do is mix the variables. Okay, when I get over here to do my u substitution, I'm going to need everything in terms of u. Okay, but that's okay because we have this expression up here, right? And if we want to know, well, what is the square root of 2x in terms of u? It's u minus 1. I can solve for the square root of 2x up here. Okay, we can say that u minus 1 equals the square root of 2x. So dx is going to be u minus 1 du. Because the square root of 2x is equal to u minus 1. Okay, so that said, I can rewrite my problem as the integral. Okay, on my denominator, I'm just going to have u, and then for dx, I've got u minus 1 du. Okay, well, as I mentioned before, we can distribute that u in our denominator. And if I do that, we get u over u, which is 1, okay, minus 1 over u. Okay, the integral of 1 du is just going to be u. And of course, the integral of 1 over u du is going to be minus the natural log of the absolute value of u plus c. Okay, well, if we go back to everything that we knew about u and x, u is equal to 1 plus the square root of 2x minus the natural log of the absolute value of 1 plus the square root of 2x plus c. All right, so if we wanted to kind of simplify this, I got a constant 1 and I've got a constant c. It's still an arbitrary constant. It's just not the same arbitrary constant. So what we'll do is write this as the square root of 2x minus the natural log of the absolute value of 1 plus the square root of 2x plus, I'm going to call this C2. Okay, it's a different arbitrary constant. We have to be careful about using that constant over and over again. So we might even make a note that C2 is equal to 1 plus the original arbitrary constant. So this is different from the C that's up here, but it's still going to be, some arbitrary constant. And so that's how we do that. All right, one more. This time we have definite integration. We're integrating from 0 to 4, 5 over 3x plus 1. Okay, and this one I think is going to be pretty straightforward. We've got u equal to 3x plus 1 since it's in the denominator. And I already have a pretty good idea of how this is going to come out. We just got to make sure we got all our parts and pieces. So u equals 3x plus 1. And it follows that du equals 3 dx. Okay, or we can say du over 3 equals dx. So this looks like the integral. All right, with this 5, I'm just going to go ahead and bring it outside of integration because he's not working for us. All right, and then in my denominator, I'm going to have u. And then we're also going to have 1/3, so I can divide the 5 by 3 dx, or rather du. So we get 5/3 times the integral of 1 over u du. Okay, and our new limits of integration would be from 1 to 13. So we got 5/3 times the natural log of u, where we're going to evaluate that from 1 to 13. So that's 5/3 times the natural log of 13 minus the natural log of 1. Natural log of 1 is 0, so we get 5/3 times the natural log of 13.